Relationships between sets. We will focus on equal sets and subsets. You will find this on page 68 in the Mathematics Ordinary Level textbook, y equals mx plus c to success. Equal sets. Two sets A and B are said to be equal, A equals B, if and only if both have exactly the same elements. Let's look at an example. Let A be the letters from the word idleness and B the letter from the word linseed. Is A equal B? Okay, by listing the elements of sets A and B are as follows. Okay, let's start with A. Remember, we don't repeat a letter. So there's a I, a D, a L, a E, a N, and a S. Linseed, there's an L, a I, a N, a S, a E, and a D. Now, if we start comparing it, we will see, okay, you can even, if you didn't write it in the same order, you can do it like this, like you would have done in primary schools. So that one goes with that one goes with that one, the S with the S, the E, exactly the same. So both sets A and B have the same elements, therefore A is equal to B. Two sets with different descriptions can be equal. Okay, so the description was different, or the words were different. Okay, let's look at, you can stop the video and do try now 4. You can continue the video as soon as you are finished. Okay, let's start. Let x, this is builder set notation, x is a digit from the phone number. Okay, and y is also a digit from the phone. And then is x equal to y? So let's start with x. Okay, now just start, there's a 0, there's a 2, there's a 7, there's a 6, I already said 7, already said 2, there's a 1, there's a 4, and 2 and 1 I already said. Okay, that's finished. And then the next one, let's look at y. Okay, it's again 0, and then it's a 2, okay, 2, let's just do it like this, 0, and then it's 2, and then it's 7, and then it's 6, and then it's going to be, okay, 2 is already there, 4 is going to be there, 1 is going to be there, and 2 is already there. Okay, so let's just, that last comma must not be there. Okay, so if I look at this, so it's 0, it's 2, it's 7, it's 6, and it's 1, and it's 4. Exactly the same. So therefore, set x is equal to set y. Finish. Okay, let's look at the next one. Subsets. When each element of set A is also an element of set B, then A is a subset of B, and we write A is a subset of B. Okay, two sets are also subset of each other. Now, I want to explain it here to you. If you see that equal sign, it means when two sets have exactly the same elements. So it's almost like this two with subsets. Okay. Of the first set are also elements of the second set. And if it's not, if they don't have exactly, then I just make the not, just a stripe through. Okay, but now, let's go take it a bit further. When each element of a set A is also an element of set B, but set B has more elements than set A, then A is a proper subset of B, and we write it. So you see now, we don't put the equal sign. If it's exactly the same elements, we put the equal sign, and we just call it subset. But if it's just part of the whole set, then we don't put the equal sign, but we call it proper subset. So when each element in the first set also belongs to the second set, but the second set has more elements than the first. And again, if it's not, then we just put across. There is at least one element in the first set that does not belong to the second set. Okay, let's look at an example. Okay, let's start here. We call a set with no elements an empty set or null set. It is represented by the symbol, so it's almost like a zero with a cross through, or indicated by curly brackets with nothing inside. Okay, an empty set is a subset of any set. Okay, so if I ask you in the next one, list all the subsets of 1, 2, and 3. Now remember, it can be proper subsets, it can be subsets, all of them. So start with an empty bracket. Then start by just putting one element in the bracket. Then start by putting two elements, so the first and the last, or you can say the first two, the last two, and the first and the last. And then, as soon as I put all the elements, remember, because this was proper subsets, and this one is just a subset because it's having all the elements. Okay, so proper, and this is just a subset. So a set with n elements has 2n subsets. Therefore, a set, there's 3 elements, so 2 to the power of 3, that will be 8. So let's count 1, 2, 3, 4, 5, 6, 7, 8. Excellent. Okay, note a set can be a subset, for example, 2 and 3. Then 2 and 3 is the element of A is in the P. The number of elements, a number is an element. Okay, so then 3 is the element of A. So basically what I'm trying to say there to you, if you write subsets, put the curly brackets around. Otherwise you will say 3 is an element of A. Then you don't put curly brackets. Okay, stop the video and do try now 5. You can continue the video as soon as you are finished. Okay, list all the subsets of A, B. Now this is a bit easier because there's only 2. So let's just start there. If I look at this one. Okay, so if I start, let's just take another color. So always start with the empty one. Just want to get my pen correct. And I will say it's a proper set subset of the whole set A, B. And don't forget your brackets. And then I start putting in one element. So first just A. And then B. Now that bracket is too curly. And then I'm going to start by putting everything in. And now I put the equal sign. Okay, so this was proper subsets, and this is just a subset. And can I just see if I have the correct amount? Because it's 2 to the power n. And in this case, n, how many elements were there? 1, 2. So it will be 2 to the power 2. So how many different proper subsets and sets must there? 4. So 1, 2, 3, 4. And that's how I can control it. So if there's, I'm just going to show you this one. If there's, for example, 4 elements, 1, 2, 3, I'm not going to do it, just going to show you, then it will be 2 to the power of 4. That will be 2 times 2 times 2 times 2, that will be 16. So then I must find a total of 16 different proper subsets and one subset. But in total, 16.